All right, here I am, folks. Here I am with Dr. Jeffrey Wozniak and Dr. Blake Gimbel. Thanks, fellas, for joining me. I really appreciate this.
Oh, thanks for the opportunity, Jeff. Happy to be back.
To be back. It's your second time, it's your first time. Dr. Gimbel, how are you?
I'm great. Thank you so much for having me. This is a great experience. I've never
Yeah.
done a podcast before, so
Oh,
really
you
cool.
never. So do you
Yeah.
listen to them though?
Oh, I do. Yeah. Big fan of your show. Big
Oh, he's
podcast listener
buttering
in
me up,
general.
folks. Well, that's awesome, Blake. Listen, first of all, if you move to another career, can I suggest private investigator with that name? Oh boy, oh boy, oh boy. You
It's a
know what
good
I'm
one.
saying? You could
Yeah.
you could change it around a little bit, but wouldn't that be true in saying like investigator, private eye? Isn't that a little bit about your job, right?
Yeah, in some ways, you're right. Yep.
That's yeah,
Some
cool,
similarities
cool.
for sure.
So this is awesome because we have lots to talk about. And so the way that we're going to structure this is we're going to talk about follow-up study on choline. You know, we did a podcast it was episode 56. You can check that out. And I talked this a couple years ago, my friend Dr. Wozniak,
Has been.
2020. Okay, so without further ado, let's just get right into it. So bring me back to the study on choline. Bring me back to why you even approached that for a study, for further investigation. What did you find out? I'll repeat this stuff. What did you find out? And then, of course, we'll go into your follow-up as well.
All right. Well, thank you for asking. This is a study that we are doing over the long haul. So we've been at this probably about a decade now. And I know your audience is familiar with choline. There's a lot of discussion, on Facebook groups and various forums that family members talk about choline, and that's fantastic. We love it when the work that we're doing here in the laboratory and in academia gets out into the public. In fact, we published a paper last year that was meant for people to read. That's a little bit less scientific jargon, a little bit more information about practical things about how to use choline. And we're hoping that families read that and pediatricians read that and that they start discussing how to do this amongst themselves.
So I'm just going to interrupt because they do talk about choline and what you're studying. And that's great that you're putting that out. But you know what happened? The media got a hold of that, right? Do you remember? And so then what ended up happening is we talked about this in the last podcast about the claims headlines tend to make. And so then our audience says, oh, this is the cure, this is the thing. And then they're backing up the truck, to buy skids of this stuff. Do you remember? So that's why I think it's so important to have from the person who's doing the work to, yes, there's the hope, and we did see this, but also it doesn't mean like, where do I get it? Because it's in my group all the time, right?
So the choline study is about an essential nutrient. So choline is a nutrient that we consume in our food, and many people don't necessarily consume enough of it with a typical North American diet. So in children, we know that this is important for brain development. The nutrient is a building block for certain parts of brain development, and it's a building block for some of the chemicals, one chemical in particular that helps our nervous system function. So super important nutrient, very important during pregnancy as well. So pay attention to that if any of your audience is pregnant or planning to become pregnant. But we decided to try to use this nutrient to see if we can optimize development that's still taking place after a unfortunate situation like prenatal alcohol exposure. There's nothing we can do to reverse the prenatal alcohol exposure itself. That happened, and whatever disruption in the developing nervous system happened, we can't reverse that. But we can optimize the rest of the development that is happening by making sure the child's brain has everything that it needs and then some to continue to develop. So that's the idea here, is not to erase damage or deficits or go back in time, but to really use this nutrient to continue to build the brain. Now, we're doing this
Hey,
in young
sorry,
kids.
that's cool. So I'm just stopping because my audience is just listening and now they're processing what you just said. So it's not necessarily a fix. What it is it's a helper. It allows the brain to reach its full potential and help with its growth and development, even if, there's been impairments caused by prenatal alcohol exposure.
That's
Am I
the
saying it
idea.
right? Like, correct me, dude.
Yeah, yeah. That's the idea, is that we're trying to capitalize on the development that takes place in this particular case. We're talking about a part of the brain that's involved in memory, especially. It's called the hippocampus. So that's really continuing to grow out into the fourth year of life, and that's what we're trying to optimize. So it's very specific. We're not, this is not a cure-all. This is not a behavioral intervention. It's not meant to make FASD go away. It's meant to just try to tweak the development of this one part of the brain that is still growing and kind of finishing itself out during the third year, fourth year of life, up to the third and fourth year of life, maybe even into the fifth. So that's the study. We're giving kids choline. In the beginning stages of the study, we gave choline or placebo. And that is how you do a proper test of something, is you randomize people to get what the thing that you're studying or to get something that doesn't have that in it. And then you can do the comparison after you've collected enough data. So I'll
Okay,
tell you about
now,
the follow-up study.
yeah, sorry. Now I'm being curious. This is curious, Jeff. Is it a controlled group? It would be the placebo group. Is that the right nomenclature, or is that the other way?
No, it's actually everyone in the study has an FASD.
Okay.
So what we do is we flip a coin, and half of the people get choline, half of the people
That was my question.
get
Cool.
placebo. That was back in the beginning. We no longer need to do that level of study. Now we're into looking at the dosing, and everybody gets some choline in the studies that we're currently doing.
Okay, excellent. Thanks. That was just right, because there's obviously different types of studies, and a control group would be a different sort of study when they would have a group of individuals on the spectrum, and then a control group wouldn't be. But in this case, the people used for your study were all individuals on the spectrum who were then separated for placebo, and then thus the distribution of choline, correct?
That's correct. Yep.
Okay, so I gotta get it, right? Like, that's the thing, because if I'm like, oh yeah, I get it, because then people ask me, and so I'm not the sharpest. I'm not the sharpest doctor. I'm just learning. Okay, cool. So what did we find? Let's keep going, because it's awesome.
Right. So in the initial study, we did find that this is a pretty tolerable intervention, that most kids in this age range can take choline without a problem. And we did it for 9 months. So parents were giving this to kids for 9 months. We chose that 9 months not because we know exactly what the right length is, but because that's a period of development in which there's enough change that we should be able to measure a difference between the choline and the placebo, or the non-choline. And what we found there was that there were some improvements in memory for the kids who got the choline. 9 months later, we measured their memory again, and we saw that there were some changes. So there were some improvements or some advantages for the choline. They're small, they don't blow the roof off, but they're measurable. And the really critical part for you and your audience to understand is that development is an additive, continuous process. And so when you intervene at an early stage, you are taking advantage of all of the development that's going to follow that point in time. And you have leverage. You have a bigger advantage to the end result when you do it early. It's like sitting on the end of the seesaw instead of sitting in the middle. You just have more leverage to have an effect.
Right.
So that's why we're doing it in these young kids.
And
People
that's the age group,
oftentimes,
right? So
yeah.
that's the study at the age group. And then we did talk about older kids, and well, it didn't show in the study. It's good to have, right? It's good to have part of your diet.
For this particular effect, we're thinking that this is going to be most effective in kids under
Right.
5 and under. So this is something that is in your diet, and it is important to have an adequate amount of in your diet. But I don't believe that there's any data to suggest that supplementing someone who's a teenager, for example, is going to have this effect, this brain development effect. If you're not eating enough choline, then it's probably good to supplement choline for a lot of reasons. Your body needs it as well as your brain. But for this particular effect of optimizing brain development around memory, we think 5 and under is really where the action is.
Has anything in the study looked about gene expression? Because that's obviously an important part of choline with that. Did you look at
Yes.
that? Are you, or am I jumping
We
ahead?
have. No, we have looked at that. We have a collaborator at Rutgers University who's looked at some gene expression changes in the blood of the kids who were in the original study. So we collected their blood pre and post, before and after, and that showed some changes that would suggest that choline was having an effect on gene expression. We don't really know what's happening in the brain as far as gene expression. You can't get in there and take a sample very easily or at all. So we're measuring this in blood, and we think we think it's showing us that there's some changes in gene expression. It's a very complicated process.
Yeah, agreed. That's why I just dabbled a little bit in that stuff, because I understand some of that stuff. So, you know where I stopped when I had to learn about splenium? I was like, okay, now we're talking about different parts of the corpus callosum. I'm gonna back out. Beep, beep. That's where you know what I mean? But like, I'm interested in it. And well, we don't have to get that deep. Let's talk about the follow-up. Let's talk about, because you first published, you did 9 months, and then was it 2.5 years, the gap because of the follow-up, correct?
It was almost 4 years. Yeah. So we did a follow-up study at around 4 years. So the kids were now 8, 9, 10 years old when we saw them. They had not had any choline from the time that they finished the study until the time that we followed them up 4 years later, or they had basic dietary choline. They didn't have anything from us. And so we brought them back and looked at the kids who got choline way back 4 years ago and the kids who got placebo 4 years ago. And we were able to detect some differences. And
so I just want to see if I can,
for the choline.
If I got this right. 18 kids were the initial placebo trial, right? And so approximately 7 years after the trial, the kids were initially 2.5 to 5 years old when they were first involved. Then you did the follow-up study, which you did executive functioning tests. You did MRI. If I was a little bit more regulated, I could say the whole word. You did MRI scans focusing on the corpus callosum's white matter structure. And that's when I stopped there, because I was like, oh yeah, what about it? And then they're like, spelenium. That's the word of the day, by the way, but we're going to back up. That you did that, and I'm not, and then tell us, like, drop the goods. What happened?
I'll tell you about the 4-year study, and then Blake can tell you about the 8-year study.
Okay.
So the 4-year study, we found that there were improvements in the choline group for nonverbal aspects of intelligence and also for memory. So the basic idea that we had was these would be permanent effects. If we intervened way back here at age, 2, 3, 4, and 5, they would be still measurable at school age kids. And that was in fact what we saw. Again, small effects. We're not blowing the roof off, we're not curing FASD, but we're optimizing a little bit of development that still has a chance to take place.
So you can help me clarify this then and break it down when we talk about, it wasn't like a huge jump, but it says various low order executive functioning. So for those who don't know, regulars of the podcast, executive functioning, planning, organizing, sequencing, problem solving, abstract reasoning. Now, these were little kiddos, but what is a lower order executive function? Like, what would that mean?
I'm going to let Blake take this one.
Blake, sure.
This was what we saw in the 8-year study.
Oh, sorry. I don't mean to be jumping around. I'm just, I'm excited.
Oh, no worries.
Yeah. Okay, cool.
Yeah, so this was our longest term study that we've done to date. So this was about 7 to 8 years on average after kids got that initial trial of choline or placebo. So that 4-year study that Dr. Wozniak was mentioning, we had a portion of those kids come back at this much later time point. So about 7 years after they did the trial. And there was 18 kids. So we had equal numbers in each group who received either choline or placebo. And we were able to look at some of these skills that you're talking about, these executive function skills. And we also had kids do the brain scan, so we could look at those white matter pathways. And what you're talking about, Jeff, is those lower order skills. So these are things like sort of how efficiently and how quickly a child processes information. Okay. And this is really important for some of those more complex skills that you're talking about, things like planning, things like working memory. You really need to be able to process information efficiently to be able to do those higher level skills. And so we do think that these findings are interesting and might have sort of real world applications for these kids.
Because you've hypothesized right so far, Dr. Wozniak, that you said if we do this early, I'm guessing that it's going to have the benefits will play out in the long term.
Right. So that's the idea with doing these very long-term follow-up studies, is to see whether the effects are long-lasting, permanent, and whether we can detect them. It gets harder to detect them the further out we go because you lose some people along the way, and the statistical power goes down when you lose people. But that's the point of doing these long-term studies. Blake can also tell you about the splenium. I know you
Yeah, we're learning about it today. That's
yeah.
nice. Blake,
Yeah,
yeah,
so
bring us in, man.
of
Plenty.
course.
I'm
Yeah,
gonna
I'll
do
do
a
my
little
best.
commercial about it too. I'm gonna do that. I'll have to do that. This episode is brought to you by Splain. I'm gonna do it. Okay, tell us about it.
Yeah, so as part of that long-term study, these kids had brain scans, and specifically we were looking at white matter in the brain. So these are these connecting pathways in the brain, and the splenium is one piece. It's sort of towards the back part of the brain, of that corpus callosum that you talked about. So this is this sort of highway of information flow between the left and the right hemispheres of the brain. And the splenium in particular, that back part of that corpus callosum, that's really turns out really important for some of these same skills that we're seeing differences between the groups. So things like efficiently processing information also turns out is pretty important for motor skills. So how well a child is able to coordinate their hands and their body. It's involved in a number of different things, but it's a very important sort of structure in the brain for development.
Here's the follow-up. How do we know that the long-lasting improvements are from the choline and not also environment, because now that they're in a good space, less cortisol. So we know the FASD brain grows differently for individuals with FASD. So did you take that into consider? Like, how would you measure that? That might be easiest for a scientist to know, but for us guys, how would you differentiate?
Well, this is the magic of randomization. So remember when I said this is the right way to test an idea is to do a randomized controlled trial. And you're absolutely right, Jeff. If we had just studied people observationally, just followed them along, we wouldn't know whether it had something to do with their diet or their environment or their education. But because we randomized whether someone got choline or placebo, in other words, we didn't pick these kids here, that live in this zip code all get choline, and these kids over here get nothing. We randomized them. And that randomization is essentially the magic in a study like this, because it should eliminate all of the other variables that, or distribute all of the other variables that could be causing those brain differences equally across the two groups. So the groups should be essentially equal with regard to sex and education and nutrition and all these other things, because we didn't assign people based on those things. We assigned them randomly. And when you get enough people in those two groups, that allows you to determine that it was the thing that you randomized that actually is responsible for the difference.
The variable that you introduced. Okay.
Exactly. Yep.
Okay, excellent. And because we want to also be hopeful here, but while maintaining, I know older parents are saying like, so is there no use for, blasting the choline besides making it a part of the diet for older individuals? Because from what you're telling me, unless I'm wrong, this selenium was sort of the essential part in that study. And does that stop developing at a certain age, which would make it, that's what you're trying to target?
We're trying to target the hippocampus, which is a different structure having to do with memory. The third thing that choline does, we talked about gene expression. We know the second thing that choline does is it's part of a neurotransmitter called acetylcholine, which is very important in memory. The third thing it does is it builds membranes or cell walls. And in one important area where the brain really needs a lot of choline is in the development of the wiring, or what Blake was talking about, the white matter. And that is what the splenium is. It's part of the big white matter bundles in the brain. So it could be that choline is impacting the development of this white matter, and we're detecting it with the study that Blake is describing.
Guys, that's awesome. I think it's awesome. Does it feel good, Blake, when you're putting the info out there? And what has been the response from like the science community or those who can like understand, the language in the study?
Yeah, I think it's definitely exciting to be a part of this type of research. I think there's a lot of interest in it. We had the opportunity recently, Dr. Wozniak and I, to go to a conference that was organized around choline. And it was really neat to see sort of the wide range of studies that people are doing using this nutritional intervention. So people doing studies even in kids who are normally developing, typically developing, and seeing
That's
some
a
benefits there.
whole conference on choline. I would have loved to have been on the marketing team.
Nerds, Jeff,
Yeah,
nerds.
that's okay. I'm a nerd. I'm a nerd. You guys are just really good at it. That's what the difference is, right? You have good skills in nerdism. I'm
Yeah.
pretty good at Dungeons and Dragons. Different nerdism, right? Although my friend has to help me with the hit points and all that sometimes, but I love the role-playing aspect. Anywho, fellas, let's move on because we got some good stuff here. That is excellent, by the way, and thank you. And we'll keep doing follow-ups. And folks, don't forget, we will have this on our blog, fasdsuccess.com/podcast. If you go there, you will see all of our blogs. It'll be on our socials everywhere. We will have Dr. Wozniak and Dr. Gimbel's work. It's going to be listed there, but there's more. You guys have been doing more. All right. Now, there was also another study that you guys did, that a paper you did, and this was about measuring brain volume through MRIs, correct? Is that right?
Yep.
You gotta say it, yeah.
Yes.
For our
Yes, that's right.
for our audio listeners at home, he's just shaking. Yeah, no
Gotta remember
problem.
that.
Yeah, no problem. Yeah, that's what my mom always said, that I have a face for radio. Anywho, okay, Blake, let's get back on track here. What was that study that you guys did, and what did you find from MRIs? Because there's Dr. LaBelle in her lab from Calgary also is doing, similar work as well. We've had her on the podcast, so I would love to hear about the MRIs to, as you put it, quantify structural brain anomalies that may improve diagnostic sensitivity for atypical brain volume in youth with fetal alcohol spectrum disorder. Well,
Yeah.
that is.
Yeah, I can talk about it.
So tell me what that means.
It's a mouthful.
Yeah.
Yeah. So some of your listeners might be familiar with this idea of growth charts. So for instance, if you go to your pediatrician's office, they might use a growth chart for something like weight. So they might take your child's weight and they're going to compare it with other children of their same age and their same sex. So for instance, you could take a plot. You could sort of see where the child is compared to others, kind of compared to where we expect them to be for the developmental stage. So maybe your child is at the 50th percentile for weight. They're sort of developing typically in that way. Maybe they're at the 5th percentile, and we need to think about ways to address that. So this study was sort of unique. We're using a similar approach to think about the brain. So we now have, recently in the past few years, researchers have developed this way of looking at brain growth charts. This is really exciting new area. And the way that they've done that is they've taken a huge number of individuals, sort of looking across many different studies, and created these data sets that allow us to do the same thing with the brain. So we can take an individual child and say, sort of, how does their brain size compare to others of their same age and sex? They give us a sense of sort of how they're developing and how they compare to their peers. And what we're finding, we were curious to look at how this new metric might line up with some of the criteria that we use to diagnose FASD. So one of the things that we use to diagnose FASD is growth differences, right? And so one of those growth differences is head size, or head size, smaller head size than expected.
Right. Yeah. So microcephaly, right? Like the head size.
Yep, microcephaly.
Interesting.
Yeah, that's the term.
Because it's part of our guidelines in Canada, but it's not. It's like it's not part of the criteria anymore. That's another conversation. Right. We could get into why we consider that. Just like the conversation about including memory in an executive functioning. I know there's different sides of that. So I'd love to talk about that too. But anyways, I digress. Keep going.
Yeah, so microcephaly, so that's one piece in many of those diagnostic systems. That's one thing that can meet the criteria for a growth difference. And really sort of how that's used is sort of as an approximation of brain size differences, right? So we think about the skull expands and grows as the child grows, and with it, the brain is growing as well. But what we know from the research is that the brain size and the head size aren't perfectly lined up. That as you get past a certain age, those two things are not perfectly correlated. And so you might have individuals who have smaller than expected brains who have normal head sizes. And those kids wouldn't be captured by that diagnostic criteria. If we're looking only at head size, we might not, diagnose that kid as having a brain development difference, as if we compared to if we looked at the brain itself. So what we were looking at in this study was looking at how these brain metrics of brain size might compare to that head size metric.
Okay. Okay. And so what did you look at in the MRI? What regions of the brain did you look at to get this data set?
Yeah, so what we looked at is we took the whole brain and we sort of broke it down into three component parts. One was looking at white matter. So we talked about that. Those are those connecting fibers. Another was looking at what's called gray matter. So these are the cell bodies in the brain. And we can break those down into the cell bodies that are sort of surrounding the surface of the brain versus those that are deep, deep within the brain. So deep inside the brain. And we're able to look at sort of across the whole brain for those three different types of cells, sort of when we look at the whole volume of those things, how different is a child compared to what we expect for their age and for their sex.
Is there a reason why it was the gray and white matter? Because so just wondering, doctor, would you think it'd be more sensitive if they used like more regional volumes, like the prefrontal cortex or the hippocampus, rather than the white
That's
and
a
the
great
gray?
question. Yeah, it's a great question. That's something that we're exploring currently. But in
Oh,
this first
cool.
study that you're talking about, yeah, yeah. So in this first study, we wanted to think about sort of at a broader level what some of these things might tell us about the brain development. But you're right, it is important to look at sort of some of those specific regions themselves as well.
Did the results vary by age?
So we looked at sort of across a wide age range. So kids in this study were ages 8 to 17. And so what we found is that there was a number of kids in our study who had normal head size, but had smaller than expected brains. And when we looked at sort of how accurately the head circumference and the brain size classified kids into the alcohol exposed or the control groups, we saw that these brain scans were actually more sensitive. They identified more kids with FASD than that head circumference measure. So when we use just a tape measure around the head, that turns out to be less sensitive, at least in this study, to capturing those kids with FASD.
And it's interesting because an MRI on its own isn't a useful tool. It can't diagnose FASD, right?
Yeah,
Because
right.
from what I'm understanding, and I'm only asking you this stuff, and it sounds like I'm smarter than I am because I've been spending time with Dr. LaBelle. That's all, because she's been on the podcast. I'm like, what do you mean by that?
Yeah.
1,000 times. Okay. So do not be impressed. I just hanging out with other people who know what the heck they're talking about. This is important, but it's also important to know that you did find, and just like Dr. LaBelle, with lower volumes with individuals with prenatal alcohol exposure, right? Like
Right.
in the weeds, what it says, if the participant scores below the crocodile, right? The 10th percentile on at least one brain volume metric demonstrated significantly lower performance on measures of intellectual function and aspects of executive functioning. Okay, compared with
Right.
participants with prenatal alcohol exposure in typical volumes above 10th
Right.
percentile. Is that correct?
Yep, that's correct. Yeah. So we were curious to look at within the kids with alcohol exposure, do these brain sort of volumes, do they correlate with things that we're interested in, which is, these long-term, these outcomes, intellectual thinking skills, attention, executive function skills. And what we found is that to some degree that seems to be the case, that kids with more developmentally different brains, kids with smaller brain volumes, did seem to be the ones that had more of those challenges.
Yeah. I remember working with a young man in a school, an all boys school, and he was in the 99th percentile for IQ, but she said giving this kid putting an IQ score is almost useless because of the deficits in the executive functioning, so IQ is what you know, and executive functioning is what you do with what you know. So we know that that's the trouble for our kiddos, is they know a lot, but it's just accessing what they know when they need to know it. So then if you're saying, Dr. Wozniak, we can introduce choline, we can, identify kids early enough, introduce choline and help with that developmental trajectory by helping those parts of the brain. And then that also includes part of the bigger picture: diet, exercise, the right environment, where then the goal becomes, even if there is exposure, even if we still, with science research in the community, have a pretty good plan that and trajectory that you could be on, aka all hope is not lost. Would you feel that way, Doctor?
Absolutely. Before I respond, I'll just maybe throw it out there that some of what we're talking about, including these articles and information about our research, your audience can go to our website to
Yeah.
pick up more details. So I'll just mention it's fasd.umn.edu. That's a University of Minnesota website. So fasd.umn.edu. So
Golden Gophers.
it is the Gophers, the toughest mascot out there.
That's awesome. I love it. Go Gophers. Yeah, for sure. And we love, you know what else we love about Minnesota? We love Minnesota high school hockey here, boys. We love it. We love it here. You guys are like the 14th province. That's what I consider. I spent lots of time in Minnesota, and I swear I'm driving and I'm like, I could be where I live in Northern Ontario. You guys are, we're same. So,
but I wanted to respond about your question about,
Thanks.
hope. Blake mentioned we were at a meeting about choline. We were just also at a meeting in Seattle. I just got back from a meeting in New Mexico, and we're spending more and more time now at scientific conferences and caregiver conferences. We have another one coming up next week in Minnesota, spending more time talking to adults who have FASD and seeing really remarkable stories about what people do with their lives and how much they can accomplish and how much they can grow, and all of the things that all of us want our children to be able to do: work, get married, have children, contribute, have social groups around them. We're starting to really get a big picture of what is possible, and the hope is most definitely there. Blake and I both know some highly functional individuals with FASD who are not only contributing on the understanding of FASD, but actually contributing to science by doing surveys of people. You probably have had some folks on your podcast.
Absolutely.
So the change makers and others. So that's what we think. We think that there is no reason to focus exclusively on deficits or limitations, and to be realistic, but also to be hopeful at the same time.
You are preaching to the choir, which is why we're FASD success. It's true, because we are learning more and more every day. You know how we get better is with my favorite saying, and that is don't hate, participate. And that's what we're going to transition to the next section, which is what really brings you here, because you are doing something brand new. And whoever is the spokesperson for this particular study that you guys are doing, please take it away. And Detective Gimbel, that's awesome. Could you be a Detective Dr. Gimbel? Yeah, you could. Oh, someone's gonna take that name and write it.
Cool.
Oh, I know it.
It's a different kind of PI, Jeff. It's a principal investigators.
Oh, that's true.
Yeah.
Oh, yeah, man. Okay. Anyways, we have fun with that. Okay, tell us where you guys and what you're doing next and what you need our help with.
Yeah. So you've touched on a number of these things already, both of you actually. One is sort of the importance of understanding the living experience of people with FASD. I think one of the things that impressed me so much about the recent conference in Seattle was people talking about how valuable the diagnosis of FASD was to them, and getting that as early in life as they could. It opens the doors for services. It helps people understand sort of what the experience is like to have an FASD. It helps
so they
educators
know that
understand how to.
Let's go a little bit more deeper with that, because I think that's important. Why it's important to get a diagnosis that comes up in my group often. And not only is, services are important, but it's important for the individual to know that this is a neurological issue. They're not the issue, as in their personality. They're not bad people. And so often they get caught in that trap because their symptoms are perceived as willful and intentional, when in fact it's neurological challenges. And so once you know that, and it's an answer to why I keep trying, I keep trying, I keep failing. Because the want is there, right? It's just the executive functioning may impede the ability to follow through with that want, or to express their emotions, or to regulate themselves when they get arousal from, being happy, sad, all of those things. And you're right. So getting a diagnosis is early is, not only for what you mentioned, but like the human side of it too. And for the moms and dads to know, to get that validation of what's going on and to have that armor to start preparing and creating that environment for their kiddos.
Right. And so, sort of the impetus for this study was thinking about what are the barriers to getting that diagnosis. We know from many of the people that we work with, many of the families, that there's so many barriers. There's high costs. There's not very many people who actually know how to diagnose and evaluate FASD. There's long wait lists. So there was for instance, one study that came out of Canada just last month that found that wait lists in Canada are around 1 year to 4 years for many families. And so this is a huge problem. And one of the things, we're trying to think about ways to address that. And so in this study, we're exploring the use of a new tool. So it's a tool that's been developed by Sarah Matson's team at San Diego State University. And what they're doing is they developed this online neuropsychological assessment tool that we think could be really useful in sort of being able to screen people who might have developmental differences related to FASD. We think it might help providers, people diagnosing FASD, to get people in more quickly and figure out what are the areas that they need to evaluate in more depth. So it could have a number of applications, and we're sort of trying to explore, we're partnering with Sarah Matson's team, where we're trying to explore how this measure might sort of map on to what a child would get if they went in to get their diagnostic evaluation. So what we're having families do is, yeah, go ahead.
Nope, sorry, I should let you finish, and then because I just have all the questions. Keep going.
So what we're asking families to do is we're sending this tool for them to complete at home. It's completed entirely at home on a computer. And we're also asking them to send us a neuropsychological evaluation report from a recent evaluation that their child had. And what this tool does is it looks at things like attention, it looks at memory, it looks at reaction time or speed. And it really, we think, might sort of map on to some of these things that kids are going to get when they go in person into a clinic and see a provider.
It's almost like an intake, like a brain intake almost.
Yeah.
And
Yeah.
it'd be,
Right.
wow, to see, okay, here's the neuropsych, here's the actual test, compare like what is going on, because I'll tell you what, something I would already be interested in is, Dr. Pai did neuropsych, still has a clinic to this day. She would do the results. She'd say in terms of decision making, the kids were okay-ish, and then the parents would be like, what are you smoking? And she goes, well, what do you mean? Look at the scores. And so then what they found out through the Iowa gambling test is that, in the clinic, there's less arousal. So I'm wondering, so then if there's less arousal, you have access to your executive functioning better, right? So you could make better decisions and possibly perform better on a test. But then counterpart to when did they get their neuropsych? Is that what you're going to measure all of that when you get that data?
That's the idea, is to look at some
Cool.
of these areas. Oh, go ahead.
No, I'm saying cool. I'm reacting.
Oh,
That's
yeah.
awesome.
Yeah. So, I mean, many of the sort of the areas that this test measures are the areas that we know can be most impacted in FASD. So that's really kind of how they developed this test, was to look at things like memory, like attention, like impulse control, and to really sort of get a sense in a similar way to what a child might do in a clinic, how different those skills are for them compared to others of their same age.
Do they check reaction time? Because that sounds, I'm not sure if they do that in a clinic, or would that be unique to the online?
There are some tests that include measures of reaction time. So one example is a computerized measure of attention. So when the child is sort of sitting on a computer and asked to pay attention and click a button when they see a certain thing flash on the screen, and to not click the button when they see other things flash on the screen.
Yeah.
And one metric that comes out of that is reaction time. But not all of our tests look at that reaction time. That's a good point that you made.
So you will get part of the test is reaction.
Right. Yeah.
What else
Yeah,
is
there's a
in it?
specific
Like what else
test.
is in it? Because that's cool. And here's why I'm thinking about this. because the parents have to sell their kids on it.
Mhm.
So they
Yeah.
have to get the buy-in. So Dr.
Right.
Detective, I need your help with the buy-in. So that's kind of cool. So it's not just answer the questions when children or kids are filling this out. Like, so what else is in it? Did you have that in mind? Like knowing like it's about 45 minutes for a kiddo to do this, or was that
Yep.
part of the team in San Diego's job to have a kid be able to either sit through or, obviously with a parent?
Yeah, I think that was a big piece of the team in San Diego, sort of their motivation for making this test as efficient as possible. So it's pretty quick. It's much quicker than, many of sort of the standard tests that we might do in a clinic. And it's getting at some of those same things, but in a really efficient way. So it's looking at things like fine motor speed. So similar to what we might do in a clinic, looking at sort of how quickly and efficiently a child uses their hands and their
Yeah.
fingers. It looks at impulse control. I mentioned that one already. It looks at how well a child can learn and remember information. It looks at sort of how well they're able to pay attention to certain things and ignore distracting things in their environment.
Yeah. So emotional regulation, it sounds like you're talking brain domains.
Yeah, exactly.
Okay, so that's what you're
Yep.
doing. Right. Okay.
Hmm.
So, because that's what the neuropsych goes through. And the way we explain it
Right.
is neuropsych is like a psychologist. Pretend your brain is like a dresser. And there are, in Canada, we do 10 drawers, right? Because I don't know if you guys check affect. I don't know if that's going to be a part of it, but it's not awesome. Anyway, it's in Canada. Psychologist goes look inside the doors, see if they're neat, tidy, working, right? And then he'll go through, or they will go through all the drawers. And if, in order to get a diagnosis, an impairment, a minimum of 3 of those, right? I always harken back to talking to Dr. Jocelyn Cook, who was part of the team to create the guidelines in Canada. And they use the CAN-FASD data set. And when they were making the guidelines, she wanted to know, does the psychologist stop at 3 or did, they go all through? And then she said to her, happiness, they did do that. What she found was 66% of individuals had deficits in 7 to 9 of those domains. That's significant. So if you can get the jump on that with this tool, is that kind of the thinking, Dr. Wozniak?
Exactly the right analogy. Yeah. It's not a replacement for an in-office professional neuropsychological exam. It's getting the jump on that. And it's also about distribution. So if we have 1,000 kids waiting for an FASD evaluation, it's going to take, a number of years to churn through those. But if those 1,000 kids can take this screening and we can sort them and take the ones who really need to be seen first and do something else with the ones who don't show any deficits, for example, or make referrals based on what we're seeing
Yeah.
there,
Wow.
or
That
even
is awesome.
just get a head start on the evaluation, like you say, and shorten the time that they need to spend in the office. All of those would be fantastic outcomes. So that's what Dr. Matson's goal is, and Dr. Gimbel's study is really we want to get a lot of people to do this who are having an actual clinical evaluation around the same time within a year, 6 months on either
Okay.
side.
So we'll get to that. Okay. Well, let's
Yeah.
get to parameters for participation. Oh, I like that. Okay. So you're seeking individuals age 8 to 16 who were exposed to prenatally. Do they require a diagnosis, confirmation? Yes or no?
Yeah, we're requesting people that either have a history of prenatal alcohol exposure or a diagnosis of an FASD. So
But
many of the kids that will be on
does
our
it need to
study,
be confirmed?
yeah,
Well, the diagnosis, they don't need to have a diagnosis, though.
Okay,
Right.
but so there's
Right.
pretty darn sure, like to get a diagnosis, it's confirmation from birth mom or a reliable source, right? And that's, birth mom for many reasons is not available. So because now they're yelling at me in my ear, Dr. Gimbel. So if they know, if all the flags are aflown and they're pretty sure, because my parents are smart and they think there's prenatal alcohol exposure, do they qualify?
So if there's sufficient evidence, this is sort of on a case by case basis. So
So
we
okay,
try to
right.
collect
So
as much
they got
information
the
as we
dually
can.
diagnosis. They got all of the things except for. But anyways, you'll take that case by case. Like, is that how that works? If people aren't sure and they want to participate, because I'm gonna get emails about that.
Yeah, if there's enough evidence to suggest to really sort of make a strong case that alcohol was a factor during the pregnancy, then we
Okay.
typically include people. Yeah. So
Now,
either
Sorry.
alcohol exposure or that diagnosis of FASD.
Okay, awesome. And my next question is there a geographical boundary to this?
There's not. Yeah,
Then
so we're
here
hoping to
we
get
go.
people.
Here we go. Okay, cool. This is important to know. So this will be the first question asked. Fellas, hear me now. Anybody could do this if you meet that criteria. What else is the criteria?
Yep. So we're looking for a certain age range. We're looking for kids who are ages 8 to 16 at the time that they would come to our study. So they can be sort of, almost close to 17, but as long as they're 16 when they get enrolled, they would be qualifying for that. We're also looking for families who are English speaking. We're looking for kids who have a parent or a legal guardian who can give consent. And then the last thing is having access to the internet. So having a computer or a tablet, something to do brain online at home.
We know that our kiddos are sprinters, not long distance runners. And so the time, is this like a survey you would find that like it saves and they could go back if it takes them multiple sessions to do that?
Ideally, we want families to be doing this kind of in one sitting. And that's kind of the way that the test was developed, was to be done,
Okay.
in one sitting rather than kind of coming back to it. So we're really encouraging people to do it that way. But the idea is that to make it as efficient as possible. So it takes about 35 to 40 minutes to complete the entire online tool.
Sometime that might be 400 years for our guys, right? Dr. W, you know what I'm saying?
Yeah.
Okay. This is what you would prefer.
Yeah.
Right.
So some of that time was also getting set up and reading the consent form that's built into the online tool. So the child is actually engaged with the tests, for a few minutes at a time, and then the test switches to the next one, and they're done in essentially a half an hour. And the tests are relatively short. They're a few minutes each, and there's a variety there to kind of keep them moving.
And parents, don't forget the ethical bribe. Because it works. No, it's true. Because look, it says participants will also be compensated for their time. Define compensation.
Yeah, so we're sending out a smaller sort of gift card for
Cool.
families that try to complete this at home,
Mm-hmm.
just to sort of compensate them for the amount of time that they try to engage in this study.
How will they know? Because they're going to be like, hey, great, I participated. Where's the payoff in terms of like, because people would want to see, hey, I was a part of that. What happened with that? Does that not come up from participants saying, hey, what were the results of that?
Yeah, we do get families that are interested in that. One of the things that we ask about in our consent is if people want us to be able to reach out to them in the future. Things like future studies, things like research results if they want some of that down the road. So people can kind of opt into that if they want it.
Could
Yeah.
we do a podcast like this where you could say the
Yeah.
results and then you could send it to them?
Yep.
Right?
That would be a
Something
great
along
idea.
those lines. Yeah, I'm just vibing. Doesn't
Mhm.
mean this will make it into the show, but so just to make sure I'm clear, because often I'm not, 18 to 16-year-old, highly suspected, lots of evidence, or have a diagnosis on the FASD spectrum, correct? Also, within 6 months to a year of getting a neuropsychological, going in to get a test. So when they sign up, waiver, do the brain online and go through that. And then when they have the test, because it's about comparing what you guys get, because you're not officially rolling this out, you're testing it, right? This is what the study is for.
Yeah.
So that's correct, right?
Yep.
Okay, cool.
That's right. Yep.
And so there will be like, obviously, we'll figure out how to do a follow-up and possibly a way where families can then see the results.
Yes. So just to reiterate, it's for 8 to 16-year-olds who have a recent evaluation or have one upcoming within 6 months.
Right.
So that we can do the comparison. We're asking for people who have known prenatal alcohol exposure. They don't have to have a diagnosis yet because they may be waiting for a diagnostic evaluation, and that's part of this study. And they do get some results from this. It's not a clinical neuropsych that they get from us. It's a computerized report of their performance on these experimental neuropsych measures. But it does give you information about how your child's performing relative to others in a couple of different areas.
Awesome. Here is the call to action. Look, I know you could put annotations in the YouTube video. Now we also do a shameless self-promotion segment.
I look good. I mean, really good. Hey, everyone! Come and see how good I look.
So hit us with that website again, Doctor, where people could just roll into it. And I'll also put a animation. So like if they're watching this video, they can click right here and just get into it.
Yep. So the website to learn about this study that we're talking about and our other ongoing studies, the website is fasd.umn.edu. So again, that's fasd.umn.edu. You can learn about this study. You can find a link to reach out to us if you're interested in participating. We can take it from there.
Hey, what else are we promoting? What else you got going on, Dr. Detective Gimbel? My audience wants to get to know you. What do you do?
Of course, yeah. So right now I'm what's called a doctoral fellow. So I'm in my last year of being of training to become a pediatric neuropsychologist. So we've talked about sort of what a pediatric neuropsychologist does in this podcast. I think in the past you've talked to some people about that. But I'll be someone who's evaluating kids with FASD, kids with other medical conditions, with other developmental conditions. I do a lot of that work right now. But after I finish fellowship, I'll sort of be independent and be able to see patients on my own.
Why FASD, dude? Like why? Because obviously it's not the sexy one.
Yeah.
It's not the, like how come?
Right. Yeah, I kind of happened across it. So when I came to the University of Minnesota as an intern, as a resident, this was at the end of my graduate training. This is a few years ago now. I really was exposed to it for the first time. So it wasn't something that I had learned about until I really got here and really sort of fell in love with working with these families. I think there's so many unique sort of experiences that people have with FASD. There's so much resilience within the community and so much collaboration. And there's so much interesting research as well. So that's sort of how I got involved, was through the research avenue and getting involved with some of the studies here. I ended up doing some really targeted clinical training. I worked at a nonprofit that really specializes in serving families and youth with an FASD. It's our local nonprofit called Proof Alliance. And that provides some really nice sort of experiences with developing expertise in evaluating FASD, but also getting to know the families and the children. And it's really sort of snowballed and continued to be a really strong interest of mine since then.
So no, like you don't like part-time moonlight as a backyard wrestler or nothing? Hey, none of that.
Not right now, at least.
Not playing shinny, Okay, that's awesome what you're doing. I think you have the right disposition for it. I call myself a cortisol cannonball because I come into a room and I could so I'm not good in a clinical setting for obvious reasons, but that's cool. And what about you, Dr. Wozniak? One of my first conferences, I was on this stage with you, pooping my pants, to be honest. That was a big deal for me.
Well, you brought the fun. You brought the fun and excitement to that.
Well, just the layman, I think. You know who I am? I'm the Winston Zedmore. That's who I am. I am the Ernie Hudson on the Ghostbusters. I am the explain to the audience what this, the science means, because once I can get it, anyone could get it, obviously. Yeah. And we just a huge passion for it. But what you do too, because you've been in this the whole time and you're obviously super skilled. You can go anywhere you want, but you stay in this population. What are you working on and what continues to motivate you? Like, my good
question. Yeah. One of the other things we're doing that's kind of cool is brain stimulation. So we have a technology that we're using to stimulate, in this case, the frontal cortex of the brain. It's very minimal level stimulation. It's done with a battery powered device that plugs into a headband, and it delivers a tiny bit of electricity through the scalp to the outermost millimeter or two of the cortex of the brain. And while we're stimulating the brain, we're having the child or adolescent do exercises for the brain, memory games, concentration games, things that involve processing speed. And the idea is that this brain stimulation just wakes up the neurons or the nerve cells a little bit more than they would otherwise be and tells them that something important is happening. And this is called plasticity. We're kind of tweaking the plasticity of just that part of the brain for 20 minutes or so, maybe into the 40-minute period that we actually have them doing the cognitive training. So it's a combined methodology, doing something with your brain while also waking the brain up just a tiny bit to say, this is important, remember this, put this into the permanent structure of the brain. And the really cool thing about this, Jeff, is this technology used to be, tens of thousands of dollars. We did this in the laboratory and bring people into the university. This technology now has advanced to the point where we can do most of this at home. And so we have a study that is not entirely remote. So this is probably not something that your audience is going to participate unless they're in Minnesota. But we're doing 3 sessions here at the university and then another 7 sessions at home. And we get the person on Zoom just like we are now. We get them set up with their equipment and we have the child or adolescent run their session with a coach while they're getting the brain stimulation at home. We control it all remotely.
Awesome. Bonus points if the thing in the brain looks like the Lewis Tully strainer from Ghostbusters. I remember when they were, their pseudoscience. Like, okay, can you call your shot in terms of your hypothesis? Remember, if we bring it all the way back to choline, you said, I think, like it's my think that if we do this early, it'll have do you have one for this study?
Yeah, we specifically wanted to do this because this we think is applicable to older kids. So where I said the choline limitation might be around age 5, and everybody asks, well, what can I do for, my 14-year-old? What can I do for my 10-year-old? This is something that applies directly because it doesn't depend on that specific developmental window like choline does. This is something that we can tailor to, eventually we can tailor it to age. It adjusts its difficulty level based on, how we program it. So this is something that can apply to a much wider age range and an older age range when kids need it. And it's scalable. It's something that we could foresee sending out to rural areas, for example, and being able to conduct this kind of treatment or intervention remotely.
Cool. You do have a cool job, but there's also hurry up and wait. And I know recruitment is a huge thing. And so if I can bridge that gap, honestly, that's why I love it. Because if that helps you, which then allows you to get your answers faster and do more and then report back to us, the community, that it's intended for, what a great symbiotic relationship,
Totally. We love telling people about this. We love having families involved. Families are just fantastic, generous with their time, and they contribute in ways that they don't even realize by talking to us about their kids and sharing their kids with us. We learn a tremendous amount about what's important to them and what we should be working on. We don't just come up with these ideas, ourselves. We listen to what families are telling us they really need and want.
Cool. And then when you're not doing this stuff, what do you do for fun?
Motorcycles, all motorcycles.
Really? I never, your stock just went up in my book, dude. What kind?
I have an old BMW right now, a 1978
and
BMW.
It's so cruising. You hit the road, mind clear. I have friends who love it. I obviously have the attention span of a gnat, so it wouldn't suit me, but that's what you like. That's your downtime. That's where you escape.
Something I love to do. Yeah, I'm teaching my 16-year-old about engines, and he wants to be an engineer.
And you have a 16-year-old.
Yeah.
Oh my gosh. If this doesn't pan out, put out skin cream, Dr. W. I tell you what, you know what I mean? Guys, this is excellent. Any parting thoughts or anything you wanted to say, before we wrapped up here?
I just want to say thank you for all the work that you're doing. You play such a big role in supporting families of children with FASD. And I think sort of the service that you provide, educating and advocating, is so valuable.
Yeah, man. Thanks.
Really appreciate it.
Well, you're going to get more airtime because of that. I appreciate that. Tell me where I send the check. Cool. Yeah. What about yourself, Doctor?
I'll just remind your audience, stay tuned to Jeff. He has his finger on the pulse of what's going on in FASD. He knows everyone from the families themselves to the researchers to the government officials. He's in the know. And again, come to our website, fasd.umn.edu, check out our studies, and we'd love to have you participate in Dr. Gimbel's Brain Online study.
Yes.
And thanks for the opportunity, Jeff. We appreciate it.
Yeah, absolutely. And so we're going to have to come back and do a follow-up episode because A, thanks for putting up with me. B, I know it's necessary, but C, thanks for putting up with me. My audience appreciates you guys, and we'll do this again soon, okay?
Perfect. Thanks, Jeff.